Hi everyone. For this video, I want to introduce us to a new type of function called a quadratic function. So when we talk about quadratic functions, what we're talking about are functions that look like this. So the biggest thing to look for is this square term. So we have some number times x squared, and we can have other terms in there as well, bx and c. So really what we're doing is we're looking at something where our terms are x squared, x, and then we might have a constant term as well. So this is what we call a quadratic function, and the one condition we have is that a is not 0. So if a was 0, what we would have happen is a lot of our terms would go away. This whole term right here, ax squared, would go away. And what would be left with is bx plus c, and that looks like a linear function. So we've talked a lot about linear functions. So if I didn't have this x squared term, if a was 0, then we'd be back in linear functions, and we really don't want them to be the same thing. All right. So with that said, let's take this form of a quadratic function and let's pack it up and put it up here for reference. So often when I'm dealing with functions, I like to look at a concrete example, and let's do that here. So I'm going to call my function g of x, or I don't know, let's call it something else. Let's call our function q of x. So I'll erase this, I'll give it a new name. Let's call it q of x for quadratic. So my function q of x is going to be x squared plus 5x plus 6. So if I look at this here, what I have is I have a 1 out here that I'm not writing. So this is really 1 times x squared. Now if we have a 1 out front, we don't really write it, but that's okay. So we have to know that that's still there as 1. And so in this case, my value for a is 1. My value for b is 5, and my value for c is 6. And so this is called a quadratic function. So in particular, this is a form of the quadratic function that we call the general form. So this is called the general form. And it's any time I have all of these terms available to me, the x squared term, the x, and the 6. If they're all showing them, we call that the general form. And one of the other forms that we have is called the factored form. So the factored form of this quadratic is x plus 2 times x plus 3. And so in a future video, we're going to see, where did that come from, and how do I actually factor these things. And so this form over here, this is called our factored form. All right, so one of the big things that we're going to focus on is how do I go between these two forms? So if I'm in general form, how do I go to factored form? And if I'm in factored form, how do I go back to general form? And there's two processes that we have here. So the first one, to go from general form into factored form this way, we call this factoring. So how do I do that? How do I factor? We'll have a whole video just to itself for factoring. And then the other direction, if we go this way, we call it expanding. So if I'm going from factored form into general form, what I'm doing is I'm expanding. And sometimes people call this foiling. So specifically, if I'm going to take two terms like these ones up here, x plus 2, x plus 3, there is an acronym called FOIL that we use. All right, so this is our introduction to the two forms, and for the remainder of this video, what I'm going to do is I'm going to clean all of this up, and I'm going to talk about how we do this step right here. So if I'm in factored form, how can I go back to general form? So this is useful because I often want to check my answers if did I factor correctly, and I want to expand it. And then when we get to calculus, when we do different computations, it's going to be very important that we know how to expand terms that look like this. All right, so I'm going to pause the video. We'll come back and we'll look at an example. All right, so we're back and we have the factored form of our quadratic here, x plus 2 times x plus 3, and we're going to walk through how do I get back to that general form. So for the rest of this, I'm going to show us a few different ways, but the one that I want to start with is that method that I talked about before. That's called FOIL. So I suspect that there's a lot of you out there that are very familiar with this. So FOIL, it's an acronym, and it stands for first, outside, inside, and last. So first, outside, inside, last. And what this is telling us is how do I multiply the different terms together. So if I'm going to expand this, what I want to do is, the first thing is I'm going to take my first terms and I'm going to multiply them together. So x times x, what I get is x squared. And then the next thing I do is I look at my outside terms. So the two terms that are on the outsides, and I'm going to add all these things together. So I get x squared plus 3x, that's my outside. Now I have to go to my inside terms, so that would be this 2 and this x here. So it would be plus 2x, and then finally I have to multiply my last terms together. 2 times 3 is 6. Okay, so if I'm foiling, this is the acronym first, outside, inside, last, and how we multiply everything together. So the final step is just to combine all of our like terms. And so what I mean by that is I'm going to find all of the terms that have x squareds in them, and I'm going to put them all together. And here we see this is the only one. So the only place I have x squareds is right here. And I have one of them, so I have 1x squared. Now I look for my x terms. Well, I have x's here, 3 x's, and here I have 2 x's for a total of 5 x's. So that gives me 5x. And then the last thing remaining are the terms with no x's in them. We call those the constant terms. And there's only one of them here, and it's a 6. And we get plus 6. So if I FOIL this out, what I did is I started in my factored form, I FOILed, and then now I'm in my general form. So depending on which direction I want to go, this is one method that we can do. We can use foiling. Okay, so I'm going to come back, I'm going to clear all this out, and we're going to see our next method, which is called the area method. All right, so we cleaned everything up, and let's see how we can use the area method to do some expanding. So where I want to start is by putting in some numbers here. So let's look at a different example before we get to the ones with x's. So what I'm going to do is in for x, just to think about it here, I'm going to look at 4 plus 2 times 4 plus 3. So if you think about this, 4 plus 2 times 4 plus 3, this is something that we can definitely compute. 4 plus 2 is 6, 4 plus 3 is 7, and we can definitely do 6 times 7. So I know what that answer is, but instead what I want to do is I'm going to leave it in this form as 4 plus 2. I'm going to leave 4 plus 3 as that way. And I'm going to think about this as an area model. So how can I compute the area of some region? So along the top here, I'm going to assume that the length of this is 4 plus 2. So what that would mean is I have some distance of 4 and I have another distance of 2, and so that might look something like this. So the length of this side here is 4, and then the length of this is 2. Yeah, so maybe that looks about appropriate to me. And let's suppose along the bottom I have a 4 plus 3. So this is going to be a little bit bigger, but these should be the same. And so that's maybe something like this. So the length of these sides are given here. So this is 4, this is 4, this is 2, and this is 3. So since I know the length and width, what I have is I have a square here and I have some rectangles. And I can compute the area of each of these things. So the way that I do that is I multiply length and width for each of these. And so what I get is, in here I get 4 times 4. And so 4 times 4 is equal to 16. Over here I get 2 times 4. So 4 times 2 is equal to 8. And then down in the bottom left I get 4 times 3, and that's 12. And then in the bottom left what I get is I get 3 times 2, and that's equal to 6. Alright, so what I would do is, if I wanted to find all of the area, what I would do is I would add all of these things up. I would do 16 and 8 and 12 and 6, and I would go ahead and I would add all of these things up, and I'll go ahead and save us here. And so what we get is we get 42. And so of course it was 42 because when I thought about this before, I thought 4 plus 2 is 6, and so this is really equal to 6 times 7, and 6 times 7 is 42. All right, so this makes a lot of sense to me. And if I come down here, what I've done is, instead of multiplying 6 times 7, I've broken it up into these smaller pieces that are some areas. Okay, so what we're going to do is, instead of 4 and 2, I really had x plus 2. So I can go ahead and I can take my eraser here and I can erase this 4, and I can replace it with an x. And I think I can do the same thing for this one here as well. Okay, so this would really be x plus 2, and this would really be x plus 3. And so for my area model, well, I have some text in here, so let's go ahead and get rid of all of this. So clear off our little board here and see what happens. And we hit this, right? So erase all this stuff really fast. And with our x's in there, let's see what we can get. All right, so the first one, x times x, well, that's x squared. And then x times 2, well, that's 2x. And then x times 3, well, that's 3x. And then, well, 2 times 3, that's 6. So this looks a little bit familiar to me. It should look very much like what we just did with our foiling. So if we come over here, I'm going to erase all of this because I don't have these anymore. But what I'm going to do is I'm going to add up all of my terms again. So if I look here, I have x squared. So that's right here. That's this term. So I have an x squared plus I have 2x and 3x. That makes 5x. That's here. And then I have my last term, which is 6, down here. And so I get x squared plus 5x plus 6. So if we compare this to our FOIL method that we just learned about earlier in this video, so I'll erase this here and let's see if we can compare it to our FOIL method and see if this works out. I think it will. So what we do is we say, okay, I'm going to take my first terms here, x times x, right? So first terms, x times x, that gives me my x squared. And so this x squared, you can see that they match up, right? So our first terms were multiplied here. Inside, right, so we did our outside terms, x times 3, 2 times x, we see those right here. And so what we do is we get a 5x. And then one more time, we did our last term, so that was a 2 and this 3 here. And we see 2 times 3 is 6, so we see our last one down here, and that's plus 6. So hopefully this area model helps give us some context for what foiling means and how it's actually related to a nice visual model. All right, so in class, what we'll do is we'll practice foiling and we'll see these in our worksheets, but we can always come back to this video as a reference. All right, so in the next one, what we're gonna do is we're gonna talk about factoring and how do we go that other way. If I'm in general form, how do I turn around and go to factored form? I'll see you then.